So for this first example, actually I'm going to do the second two, I think. So for the second example, remember, if you guys go back and look at your properties of logs, what you guys are going to have to remember is what goes which when you're working back and forth between expanding, condensing, expanding, whichever one you're doing. So product and sum go hand in hand. So multiplication and addition go hand in hand. And then quotient and difference, or division and subtraction, go hand in hand with one another. So when you're expanding, when you have a quotient or a division problem, okay, if we're expanding, that means it becomes a subtraction problem. So every single variable or coefficient or term in your expression needs to get a log with it. So if you have an x and a y, when you have this expanded, both of those need a log base with it. So what that looks like, so we have a log base 4, x to the 4th because it's on top, and then we're going to subtract the y, but the y also gets the log base 4 y squared. So it is a little more expanded than it was before. Now we have 2 logs, and it's a difference now, so they're both separated. But our properties say that we can do something with that exponent. So we have x to the 4th and y squared. So what happens is we can bring out, or bring that 4 and that power of 2 to the front. So this actually becomes 4 log base 4 of x minus 2 log base 4 of y. So all we did was take the exponent and move it out to the front of your term. And that's it. It's expanded. No exponents left. Every term in your expression has a log with it. So it is done. So that's number 10. So if we look at number 11, log base b of u to the 2nd power times the square root of v. So we don't really have any properties for radicals, guys. So what I'm going to do is turn that radical into an exponential term so that we can work with the properties for our exponents. But first, I am going to break it up into 2 terms. So I'm going to make this log base b of u squared, and because it's a product or multiplication, it's going to be plus log base b square root v. So now I'm going to make that square root v to the 1/2. So now we have 2 terms being added together. The only thing we need to do yet is move our exponents out front. So this becomes 2 goes out front and becomes 2 log base b of u plus the 1/2 comes out front, log base b of v. And that's number 11. So both are expanded. There's no exponents left. And that's pretty much it. So go ahead and try number 9, or that first example there. It's actually the easiest of the 3. But so if you have 3 things being multiplied together, you should have 3 logs, and you should have 2 signs in there. So go ahead and try to expand number 9. I'm going to go ahead and try the next 2 examples with you guys. Okay, I'm going to do this with you. I'm going to have you guys try that first one, the log base 2 of f to the negative 2nd times d over n to the 8th. But for number 13, I think the easiest thing is to just get rid of that radical first. Again, you don't have any properties for radicals, so make it into an exponential expression. So make this log base b, and so when you're doing this, the index is the denominator of the fraction. So if you have x squared, this is going to be x to the 2/7 times y to the 14th seventh over z to the 4/7. Now it looks a little weird because everything has fractions that are exponents, but that's fine. So now what happens is x and y are being multiplied together as a product and then being divided by z to the 4/7. So whatever is being subtracted, or I'm sorry, whatever is being divided is going to get the subtraction. So if you're dividing by z to the 4/7, then that's what you're subtracting. You subtract the z to the 4/7 part. So again, x, y, and z all need a log. So this is going to become log base b of x to the 2/7 plus log base b of y to the 14th seventh and then we're going to subtract log base b of z to the 4/7. So the last thing you guys have to do is pull out all of those exponents to the front of your expression. So your final answer is going to be 2/7. Can't reduce that, so we'll just leave it. Log base b of x plus 14 over 7 is 2. So 2 log base b of y. And then minus 4/7 log base b of z. And then that would be expanded. So why don't you guys see if you can expand that one right before this, the log base 2. Same idea. Make sure you're taking care of your exponents. What's being multiplied is added, and whatever it's dividing or getting divided by gets subtracted. So go ahead and try number 12. I'm going to go ahead and try this next one. These last two examples want you to just work on using your properties of logs. So they're giving you a set value for each log, and then you're going to try to use your properties to get to the requested value. Now remember, you can only use the properties of logs, guys, if your logs are the same. So in this case, for number 14, they're all log base C, which is good. If it was a log base R, M, or C, you couldn't combine them or condense them into the same expression. But it's telling us log base C of 2 equals 0.431, log base C of 3 equals 0.683, and log base C of 5 equals 1. So it's asking us to find this value of log base C of 5/12. So using the numbers that it has given us, 2, 3, and 5, can we get to 5 or 12? Well, 5 is just going to go on the top, and on the bottom, so we're going to have log base C, 5, and on the bottom, to get to 12, we can multiply, what do we have together? We have 2's and 3's. We can get to 12 by using 2's and 3's. 2 times 2 is 4, so we would need times 3. So we're going to use our expanding rules to find the value of log base C of 5 over 12. So we have 5 over 2 times 2 times 3. So if those are 3 terms, we need to subtract every single one of those. So this becomes log base C of 5 minus log base C of 2 minus log base C of 2 minus log base C of 3. And the reason that happens is you could do it like this. Because 2 times 2 times 3 are a product, you could have subtracted the whole denominator and said, okay, technically they're being multiplied together. So you could have done log base c of 2 plus log base c of 2 plus log base c of 3. And what would happen is that negative would have distributed inside there to each one of them. I just say, okay, if they're all in the denominator, we're going to subtract each one of them. But that's how we get to that step of all of them being subtracted. So now that it's expanded, we just have to say, okay, well, what's the value for each one? So log base c of 5 is 1. So this becomes 1. Log base c of 2 is 0.431. So minus 0.431 minus 0.431. And then log base c of 3 is 0.683 minus 0.683. So that whole entire expression would equal negative 0.545. Again, it's just trying to get you guys to really use those properties of logs, because if you don't know the base, how would you evaluate it? That's why it's giving you these values, and you have to know your properties to be able to solve. You have to maneuver it and move it around to be able to get the given value. So go ahead, try number 15, and let me know if you need help.